In the metallurgical branch, foundries are those factories where many metallic parts and components that will be used in different industrial sectors, such as transportation or petroleum plants, are produced. The foundry, through melting and casting process, produces countless parts of various shapes and dimensions. The melting and casting process is one of the most ancient working techniques. The first casted pieces were found in 4000 BC. In this video, we will visit Zanardi Fonderie, a company specialized in the production of cast iron items since 1931. We will show you their plant, how cast iron parts are realized, and how this company has been able to continuously improve and innovate during the years such an ancient process. JAES, leader in the industrial spare parts supply, works with companies like Zanardi Fonderie for facilities maintenance and to support the technicians to make the most accurate choice for spare parts. Zanardi Fonderie is located in Erbi, in the province of Verona, north center of Italy. They boast a production capacity 18,500 tons per year, with pieces that can weigh from 1 to 120 kilos. Our visit starts inside the design and co-design offices. Generally, the customer realizes his own drawing of the component he needs. According to this approach, the foundry designer starts the study of the molding scheme of the raw part, considering also that the material allowance has to be applied. To put it in other words, the designer has to study the shape of the mold where the cast iron will be poured in order to obtain the raw cast part. Firstly, it depends on the molding process: green sand molding or resin sand molding, the dimensions of the casting, the number of pieces that need to be casted, and the functional and dimensional requirements in order to avoid shape and dimensional defects. Secondly, it is utterly important to produce good castings without any cavities or porosities, at least where they've been machined or where they have been exposed to relevant strains. For this reason, engineers create virtual simulations of the pouring process phases to find out any possible modification that can be made to refine the filling and solidification stages of the mold in order to improve the costs and quality of the cast part. In this scenario, we're analyzing a horizontal green sand molding process with closed brackets and foundry pattern. Specifically, there are several shapes to keep in mind when defining the shape: pattern division line, undercuts identification, type and design of feeding system, feeders removal, and deburring type. The pattern division line identifies the dividing planes of the two brackets so that the pattern can be extracted from the sand mold easily. The line is defined in accordance with the dimensions and the casting shape. In this case, if the model has some undercut areas or very deep bowls so that the risk of extracting sand residues when removing the pattern is high, the cores are used. The pattern division line, or junction, determines the casting and parting line, which, depending on the processing type, will be or won't be removed. Most of the time, the cast orientation, or at least the parts that must have better characteristics, are facing the lower molding bracket, since waste and gases tend to rise upwards. Even the feeding system can contribute to this. When we talk about cores, core prints have to be added to the pattern plate in order to obtain proper core head seats for assembly into the mold. Core heads must ensure the stability of the core during the pouring process, resisting both thermal shock and metallostatic pressure. Let's now move on to the sand and molding line. The sand, mostly composed of siliceous sand, sea coal, bentonite, and water, is used to create the mold cavity in which the liquid cast iron will be introduced. The plant constantly fuels the molding line, and the quality of green sand is monitored through the control of many physical features, which basically are humidity, cohesiveness, permeability, and several other factors that determine an optimal product. The pattern plates, consisting of slabs with the pattern, the pouring and the feeding system shown above, are the result of the design study. They are used to create inside the two halves of the mold into the sand. Through the molding process, the negative print of the whole cluster, which will be filled by cast iron. The pattern plate's components, depending on the number of pieces to realize, can be made in cast iron or aluminum for large productions, in resin for medium-sized productions, or in wood for samples and prototypes. Basically, the model in this machined component requested by the client, with the addition of the necessary adjustments to produce the raw component, metal allowance, drafts, shrinkage, core heads, supports for cores, coolers, protections, etc. The cores are products that are mainly produced with siliceous sand and a binding agent that gives a certain thermal and dimensional stability during the casting process. They are used to obtain the internal parts of the raw casts, the holes, and the undercuts parts, that is, those areas which stay in the shadows, compared to the direction of the pattern plate extraction after the molding phase. There are many technologies for cores manufacturing. In Zanardi Fonderie, they are obtained through the Ashland process, cold box urethane. In the cold box process, cold hardening of the cores is obtained through a gaseous catalyst, a mini. In order to regulate the flow of the cast iron during the molding and filling, and to detect impurities such as slags or sand particles that could give birth to some defectiveness on the casts, usually some extruded ceramic filters with regular holes are used, or alternatively, some silicon carbide spongy filters. These filters are located in special housings that they are directly obtained through the forming process. Following the molding steps necessary to obtain two green sand half molds, the operators place cores, the coolers, and the filters on the lower molding bracket, while on the upper one, some holes whose function is to facilitate the exit of the exhaust gases generated during the filling and subsequent combustion of the cores will be created. Once these operations are finished, the two semi-molds are coupled and closed through a clip closure system. From now on, the whole mold is ready to be filled with the liquid cast iron on the next pouring station. In the next video, we will discover how melting ovens work and how cast iron is cast inside the moldings.